This is part 2 of our Unit 3 review. In part 1 we did 1 through 6. Now we're going to look at problems 7 through 15. In problem 7, it wants to know what the x and y intercepts of this linear function are. Because it is given to us in standard form, we can go ahead and use the cover-up method to find each of the intercepts. So we cover up the y to find the x-intercept. We cover up the x to find the y-intercept. Here we're going to divide both sides by -6. So this is my x-intercept. And this occurs at -4/3, 0. My y-intercept is at 0, 4. So the order pair there is 0, 4. Because remember that for an x-intercept, the value of y is 0. That's why we can cover it up. And for the y-intercept, the x value is 0. That's why we can cover up the x term and just solve for y. What is the slope of the line below in problem number 8? So got 2 nice points, well actually 3 really nice points here, here, and here. So I count down 1, right 2, down 1, right 2. So my change in y is down 1, my change in x is to the right 2. So my slope is going to be a -1/2. For problem number 9, they want to know the slope of the line given by this equation. For this one, we have a couple of things we can do, but basically the easiest thing to do is going to be solve for y. So when we solve for y, we move the x term first. So I move the x term either by taking care of it on both sides or moving it to the other side and making it the opposite. If that was a positive, over here it's a negative. Then we divide by the number in front of the y. So I'm going to get y equals 1/3 minus 4/3x. At this point, what we need to do is look at the number in front of the x term, and that's our -4/3. So our slope in this case is -4/3. Okay, they give us a formula in number 10 to help us out. We want to find a formula for the nth term of this sequence. So what we're going to do is take 17.2 and subtract 23.7. So in our calculator, we just do 17.2 minus 23.7, and that gives us a -6.5, which makes sense because it's going down. So let's make sure that that holds true for all of them. So 10.7 minus 17.2 also gives us -6.5. And then the last one they give us is 4.2, and I can subtract from that 10.7. And that also gives us a -6.5. So my common difference here is going to be -6.5. We don't know what n is, so we simply write down the equation. A sub n equals the first term, and here's my first term. This is my a sub 1. So I take 23.7 plus, or since the common difference is negative, we can go ahead and just call this subtract. 6.5 times, and we don't know what n is, so we just have to keep it at n. So this is our nth term equation for the sequence that begins 23.7 and has a common difference of -6.5. Number 11 says, what is the slope of the line containing the points shown in the table? I'm going to go ahead and do this with change in y over change in x. But you could also do this in stat, where this is our L1 column and this is our L2 column. So to get from -6 to -8, I'm going to subtract 2. Here's also subtract 2, and another subtract 2. Hopefully this is a common difference over here as well. To get from -7 to -4, I'm going to add 3. Here again, I'm going to add 3. And finally, to get from -1 to 2, I will also add 3. So if I'm going to take my change in y over my change in x, take my -2 over my +3, or we can just say that slope is -2 over 3. Okay, for number 12, what is the slope of the line contained by these points? Here's my first point, so there's the x value of the first point, y value of the first point, x value of the second point, y value of the second point. So I just use the formula, y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. My y sub 2 is 5, my y sub 1 is -15. My x sub 2 is -2, x sub 1 is -8. At this point, you just do alpha y equals in your calculator, and including the parentheses, you just type all of this in. So we put the 5 minus -15 on top, and then we put the -2 minus the -8 on bottom, and that simplifies to be 10 over 3. Because this would have been 20 over 6, and then that would simplify to be 10 over 3. Okay, for problem number 13, it says, what is the slope of the line given by this equation? Well, our slope is simply the number in front of the x, so our slope here is -4/3, because we are looking for the number in front of the x, and that is a -4/3 because every number has a sign and every sign has a number. It says, what are the x and y intercepts according to the data in the table for problem number 14? Now we can find our y-intercept right here. That is the order pair 0, 6. So we have a y-intercept occurs when y is equal to 6, and that's the order pair 0, 6. But we do not see a 0 in the y column, so I'm going to need to extend this table. Now I notice that if I go down this way, things are getting bigger, so they're getting further away from 0, and I need a 0 in this column, so I'm going to continue this way. Notice that it goes down 2, down 2, down 2. So the next one it goes down would be a 2 here, and then after that a 0. So I've got to get 2 more values over here. So in the x column, -6 to -3, that's +3, +3, +3. 3 plus 3 is 6, 6 plus 3 is 9. So here I have developed my x-intercept by simply extending the table and looking at how the table was counting. So the x-intercept occurs at 9, so that ordered pair would be 9, 0. Okay, finally, problem number 15. It says, which of the following represents a direct variation? Remember that direct variation must go through the origin. That means that the ordered pair 0, 0 must be in its table. So over here we have x equaling 0, but this is a 3. So that's not 0, 0, so 1 is not direct variation. In answer choice 2, x is 0 and y is 0, so this one is a direct variation because 0, 0 is part of its ordered pairs. For the graph here, we see that it does actually go through the origin, so this one also has 0, 0 as an ordered pair. Here, it doesn't go through the origin, so this is not direct variation because it doesn't have 0, 0 as an ordered pair. Here, if I let both x and y be 0, you would get 0 equals -4, so that doesn't work out. So let's go ahead and show you what that would look like. If I replace both x and y with a 0, because 0, 0 needs to be an ordered pair in order for it to be direct variation, so we end up here with this false statement, so this is not direct variation. And then finally, item number 6. If I let x and y both be 0, I end up with 0 equals 0, which is true. So this one is direct variation. So this one also works. It is a slope, but it doesn't, it's just that y equals k times x form. So there's no plus or minus to it, so that's direct variation. So this is part 2 of your Unit 3 review. Please make sure that you have this completed before test time.